Hello and excuse me, welcome to this module on managing project quality. Once again, like the other modules, it's wonderfully high level, it's to the point, and intended to give you a wonderful overview and introduction to the processes of managing project quality. So, and again, with all the other modules, if you have any questions at all, just drop me an email and I'll do my best to get back to you as fast as I can. So let's dive right on in. This is my goal, is to get you to accept that quality is it is a worthwhile investment, and that it's worthwhile stopping mistakes before they happen for lots of reasons, not just financial but reputational, things like that. So we want you to build quality into your projects rather than just hope that everything turns out okay and then think, oh, if they don't, we'll fix it afterwards. Because the real world is quality is sort of just assume that just because people are going to do work, it's going to be quality. And also that if you've done the work, that you put them out there, that you'll just fix things if they break, which is not a good way to approach things. Fixing things after they break shouldn't be seen as part of your project costs. And often they're not part of your project costs, are they? Your quality decisions will impact the product owner or the asset owner, the maintenance people, whoever's responsible for whatever it is that you build. Your decisions in poor quality on the project will be passed directly on to them. So that's another thing to keep in mind. So at least talk with them about your decisions to have poor quality. Let's start with a definition. This one, I believe, is from one of the PMBOK guides, probably version 6, I imagine. Version 6 or version 5. Just obviously a reminder on that. The PMBOK guide up to version 6 was essentially the book that you now know of as a process groups practice guide book. And the new PMBOK guide version 7 and I guess onwards is a principles-based approach to capturing the body of knowledge. So look, let's start here with what quality is. There's a couple of important words here. Quality is the management of the degree to which a set of inherent characteristics fulfills requirements. So there's two things here, and if they're equal, that's quality. The observable characteristics that you're able to observe and measure, do they match the requirements that you set? If they do, then that is a definition of quality. So if you set a particular set of requirements that aren't great, but you can observe that happening, that is the definition of quality according to you. Quality, although we like to think it's some sort of objective concept, maybe good or perfect or something like that. Quality is really what your definition, obviously the client, the user, any other stakeholders will have their own definition as well, so make sure you check with them. But as long as you recognize that it's the management of the degree to which a set of inherent characteristics fulfills requirements. So you do need a defined set of requirements, and you need to be able to observe a particular set of characteristics and measure them, and if they're equal, that's quality. Look, just a quick word. The difference between quality and grade, it's just a term worth exploring. We're going to deal with quality here. Sometimes people say, well, is it high quality, high grade? Is it the same thing? No, they mean different things technically. In the real world, you may use the terms grade and quality interchangeably. I'm not, though. I'm going to use the word quality to mean the degree to which a set of inherent characteristics fulfills a set of requirements, as we discussed on the previous slide. Grade actually refers to the amount of features that something has. And the best way to give you an example of this is Toyota. Well, many brands do this as well. Sony and Sanyo do it. They're the same company producing the similar products at the same quality. But the grade is differentiated by the brand. So Toyota has Toyota and Lexus. For all intents and purposes, the quality of the cars branded Toyota and the quality of the cars branded Lexus are identical, but the grade is different. Lexus tends to be its premium brand, so cars that have Lexus on them tend to have more features in them, leather seats, heated seats, different braking systems, extra features in them. I only know this one because my father brought himself a Toyota few years ago, and it was the highest level of Toyota, but the car was exactly the same as the lowest level of Lexus. And he always used to say that he was driving a Lexus anyway, because if you just changed the badge and put leather seats in it, it was a Lexus. And that is true. So when I use the word grade, I refer to features, and quality, I refer to the previous definition. So low grade is fine. You can produce a product with low amount of features as long as that's what the client wants, or that's what the deliverable is supposed to be. Low grade is fine. Low quality is not. Okay. So you can build a low grade product with low features to a high quality, and you always should. Well, we could cut short this whole module because I could just simply point you to William Edwards Deming. Mr. Deming is often referred to as the father of modern quality management. There are other practitioners, but he's the one probably in the 20th century, the second half of the 20th century, who contributed most to the rise in the profession and knowledge of quality management. He also gave the plan, do, check, act cycle to the profession of project management, and we covered that in the very first module on foundational concepts as well. The plan, do, it was called the Stewart and Deming plan, do, check, act cycle. So this is what I recall about Deming. He was I think he was a statistician or something before the Second World War, and he ended up working for the United States Department of Defense in logistics. And he used his statistical background to basically apply this to getting the logistics for the American war effort humming along very nicely. After the end of the Second World War, him and his particular approach to quality, which meant do things right the first time and figure out why they aren't, and improve and continuous improvement. My understanding, and paraphrasing his life terribly here, or simplifying it terribly, is he tried to set up himself as a consultant in the United States, and at that time a lot of United States industry was focused on other things besides quality, and in fact saw quality as a profit loss, because I know there was some organizations that thought, well, if you build it so it breaks down, then people have to come back and buy a new one, whether it's washing machines or cars and things like that. Whereas he was, well, things shouldn't break down, they should be built to a sufficiently high quality. He couldn't get any work got work, but not a lot of it, as much as he wanted in the United States, and he ended up going to Japan and working there for companies like Toyota, and they had a focus of everything must be about quality. So he did a lot of work there, and then because of the work he did there, he got work back in the United States, and finally when the United States industry realized that at the time made in Japan meant really good quality. And there's lots of really interesting stories. If you get the time, look up the story. I'm not sure how you'd Google it. Look up the story of I think it was a Ford motor car, and some of the cars were being sold with gearboxes made in America, and other cars, just because the sheer numbers being produced, had gearboxes made in Japan. And I believe that after a few years, customers began to request that the car they were buying had the Japanese gearbox in it because it didn't break down. Anyway, so everything I'm about to teach you or introduce you to, it's not necessarily teaching in this format, introduce you to comes from the work of W.E. Deming. And so if you do want to know anything more about Deming, he's got a website and you can check his books. The great thing is that there's a lot of people who've taken his work and expanded it even further. And one of his limitations was, as a statistician, he tended to interpret data as a massive set of tables, and he knew how to interpret them. And a lot of the diagrams and methods that I'm going to show you is just some of his Japanese contemporaries, notably Ishikawa, who took his statistical analysis and turned it into nice graphical, easy to understand ways of detecting, measuring, and tracking quality. So anyway, as I said, you could cut this module short just by going and reading a book that he had written on quality, and he's still regarded as one of the pioneers in the field of quality management. And central to everything that he said was this. It sounds simple. Stop mistakes before they happen. It's that simple. you should have prevention of mistakes over inspection to find the mistakes. We often use this analogy: it's better to have a fence at the top of a cliff than an ambulance at the bottom. So it's better to stop people walking off the cliff than fix them once they fall off the cliff. Because generally speaking, and generally, it costs more to fix an error after it's occurred than to prevent one before. There are certain instances where you may decide that the cost of preventing an error is greater than the cost of fixing it if it does occur. Obviously, there can be health and safety considerations or reputational damage, things like that. But generally speaking, we want you to put the effort in up front to prevent the mistakes before they happen and whatever it is that you're building. You should double check that. What we don't want them is getting back out to the client or out to the real world as well. And in terms of the costs that you will incur to fix errors, yes, there are financial costs. Absolutely. You will pay money to fix things. I just saw on the internet today, and I don't think this will date this particular module. I don't think you'll be able to figure out exactly when it was recorded, because there was another story about a large multinational automobile manufacturer having to do yet another recall of cars. In this instance, it's you can look it up. It's the old airbag issue of randomly going off. But this issue has been going on for years and years and years with different car manufacturers who all use the same airbag supplier. And just today, I saw that in the United States, this particular car company had given an order, I think it was to 50,000 Toyota drivers for cars from 2003 to 2004 particular models to stop driving them immediately. Now, obviously, the particular car company in question has to pay for all of those cars, those 50,000 cars to come back in and have the change made to the airbags. But the reputational damage is done as well, both to the car company and the manufacturer of the airbags as well. So there's lots of different damage that you will suffer. If you can figure out what time of year I recorded this just by that story, there's bonus points where you email me and say, well, based on that, I think you recorded this in this month of this year. Bonus points. Anyway, so it's not just money, it's your reputation, future business, all of those sorts of things that are at stake if you get a reputation for putting out poor quality that needs fixed afterwards. And this doesn't matter if you're putting out houses or software code. If you build stuff and it's of poor quality and always needs lots of maintenance and there's breakdowns in it, or if you develop code, software code, and it's known as full of bugs and updates and there's lots of holes in it, then this is your reputation. So it's more than just money. So the first step in quality management in a project is planning for quality. This is where you sit down, you do your quality management plan. It's one of those subsidiary plans of their overall project management plan. You'll sit down, you'll identify your particular approach, you'll set down your quality specifications, the testing assurance techniques that you're going to use, outline the responsibilities, any checklists, but also your process improvement plan. Because one of the key elements of good quality management is continuous improvement, or Kaizen. I'll write that up there. Kaizen. And Kaizen is a Japanese word that my understanding is loosely translates as good getting better or continuous improvement. So one of the key points we want you to take on board is good is never good enough. You can always do better, and you should always be tracking your particular approaches to quality and making sure that you are getting better. Will you ever reach perfect? No, because there is no such thing as perfect because humans are involved. So this concept of Kaizen, of continuous improvement. So when you're putting together your particular quality management plan, you do want to consider, as I said before, the cost of quality and the cost of poor quality. So there is a cost of quality. You will have to pay a little bit more. You will have to get people to work a little bit longer. You will need a testing regime. You will need metrics and checklists. But the cost of poor quality will generally always outweigh the cost of quality. I don't know. I'm just trying to think of an example where it wouldn't be. Maybe you're making lollipops or something. It's better just to refund people who find too many bubbles in the lollipop or something. But generally speaking, the cost of poor quality vastly outweighs the cost of quality once you take into account financial and reputational. But please keep in mind, as I've already mentioned, that decisions that you and your team make about quality on your project can affect others. So if you decide to save project costs by skimping on quality and handing over to the product owner or the asset owner a lower quality product, you are simply transferring the costs of low quality onto them. They'll have greater maintenance costs, operational costs, warranty costs because of the decisions you made to save money during the project. So in all of your planning for quality management, please make sure you take all of this into consideration. I know on one project I worked on, we made an accidental mistake about this. It was for an urban restructuring project. I've mentioned it in other modules. It was 2.5 years, $20 million. It was to build a new pedestrian shopping mall. And we did not take into account that we'd built this beautiful new shopping mall, and the old shopping mall, pedestrian outdoor shopping mall, was costing the local council somewhere around $30,000 a year for cleaning, $600 a week for a cleaning machine to run through it. What we'd done to it now required that to go up substantially. And we forgot to tell the asset people. So ironically, the quality decisions we made, which were the right decisions, by the way, we forgot to communicate the extra cost of quality to the asset team, and they weren't happy, by the way. And rightly so. We should have let them know that the client, who was their boss as well, wanted something of quality, but they had to get more operational costs for that. So that was an inverse example. But your decisions about low quality, you can't hide the costs. You're only transferring them onto somebody else. So here are just a brief introduction to some particular quality approaches. Some of them you may have heard of. You may work for organizations that already use these particular quality approaches. And if you do, that's great. You've got a head start. If not, here we are. One of the more common ones that you'll see is ISO 9000 or 9001. It's an international standard. That's what ISO stands for. It's French for International Standards Organization or something like that. There's an ISO standard for everything in our lives, by the way. There's ISO standards for the buttons on the shirt. There's ISO standards for glasses and the screws in my glasses. There's ISO standards for the computer screen I'm looking at. There's ISO standards for the desk that I'm sitting at. There's ISO standards for the windows over here. The light behind me. There's an ISO standard for light bulbs and electrical works, and ISO standards for everything. But one of the more common ones is ISO 9000 and 9001, which basically says you've got defined processes and you make sure that you follow those processes. And if you've got the processes and can prove that several times a year you check, and that if you find you're not following the processes correctly, you do something about it, you take corrective actions, then you can get ISO 9000 or 9001 accredited. That's slightly different there. And this is often used in the world of procurement. You may have to be ISO 9000 accredited to get particular work from some companies. So that's ISO 9000, but it's all about process, not about the product. It's all about having processes in place. So theoretically, you could have an ISO 9000 certification just because you've got processes that say we do things badly and we can prove that we follow the processes to do things badly. Anyway, theoretical. I don't know of anybody that does that. I do know that many years ago, long time ago, again, just showing my age and how long I've been doing this, back in the late 90s, I worked at a particular engineering consultancy firm who was very proudly ISO 9000 accredited and spent a lot of time each year proving that they had all these processes for certifying their surveying gear, their measuring gear, their filing systems, everything. But as a funny story, back in the 90s, late 90s, which seems like such a long time ago, it is a long time ago, I always remember that if the ISO inspector ever turned up unannounced, because they can sometimes, that the receptionist would send a message internally via our computer screens, ISO inspector has just arrived. And basically anything that we knew was non-complying on that particular date that we might fail the inspection would just disappear into drawers and cupboards very quickly. So if the ISO inspector did do a random inspection, everything they discovered was compliant. It wasn't saying that we weren't compliant, but just that on that particular day, we didn't want to fail a random one. So keep that in mind. Okay, so another approach to quality management is TQM, total quality management. And this just says that quality isn't just the responsibility for those doing the making, it must be embedded in the company culture. It must come from the CEO, the COO, the CFO down, and everybody must buy into the fact that quality is a strategic advantage, that it's a reputational advantage, that it's a marketplace advantage, and that everybody focuses on it. And that quality is seen as an essential and non-negotiable business attribute. And not only just quality, but again, that concept of Kaizen, continuous improvement, always getting better. So, I think the most famous company worldwide for this would be Toyota. And a lot of what we show you, or what I'm about to show you, it was developed in with Toyota as well. But the Toyota automobile company is renowned for its approach to total quality management. So remember, it's not just the people at the bottom doing the work that must make sure quality is there, but it comes right from the top level down. And that's an interesting concept, because I know I wrote a blog a few years ago about amending this concept to be calling it total project management, TPM, because for me, project management can't just be the passion of the practitioners down the bottom of any organizational chart. For project management to truly make an organizational difference, it needs to be fully supported by everybody, including C-level, CEO, CFO, CIO, all of that. So I did write a blog a few years ago. You can probably find it if you search for it. It might even be on this website that you're watching this through, because I am trying to transfer all of the blogs across eventually. So look out for that one on total project management, which is just me saying, hey, how about we take this idea and apply it to project management. Six Sigma. Six Sigma is just a nice way of saying no mistakes ever. You may know somebody, or you may yourself be certified in Six Sigma. You might find somebody who's a black belt in Six Sigma, or is it, let me just check, always get confused with if it's yellow or green. I just got my phone out to Google this quickly. All right. So there's yellow belt, green belt, and black belt, and there's white belt, yellow belt, green belt, black belt, and master black belt in Six Sigma. And these are all courses that you take and study that you do to become proficient and certified in this. And generally, when I teach project management in a class of 30, I'll find at least one person who's certified in this. So you may be certified or know somebody who is. It's basically developed by Motorola, and basically says quality is everything. And it's called Six Sigma because if you remember your stats and you remember a normal distribution of data, and if this was the mean here, that's the mean there. And you'll know that standard deviations is the average of the average distance away from the means of the data set, and one standard deviation either side of the mean, so either side of the mean, that there should account for about 65% of the data. Three standard deviations either side of the mean out here, three standard deviations would account for about 99% or 99.5%. And six standard deviations either side of the mean should account for 99.999% of a population in a normal distribution. So it's basically just saying no mistakes ever. And you're happy that this does exist, because there are some companies who want to be producing the Six Sigma reliability. If you buy parachutes, you want to know the company is building to Six Sigma reliability. Medical devices like heart defibrillators, things like that, definitely Six Sigma reliability. But there is a lot of cost involved. So this is one of those issues of cost of quality. You'd have to decide whether Six Sigma was right for you. And I know that here in New Zealand, that the cell phone operators, for a company to own a cell phone operation license in the country, they have to agree to abide by what's called 5 nines reliability. 1, 2, 3, 4, 5 nines, Six Sigma, for the emergency number, which basically means that out of every 100,000 times somebody dials the 111 system here in New Zealand, 111, that 99,999 times it must go through. So Six Sigma is appropriate where quality is absolutely essential. So yeah, have a look at that. Ask around your workplace. You'll probably find somebody there who is Six Sigma certified. Now what we'll do is I'll take you through some of the specific tools and techniques. And again, just keep in mind, these were developed by Mr. Deming. And of course, he was a statistician, lots of tables. You can actually see an example of what he did online. But it was people like Mr. Ishikawa and the contemporaries that said, these are a little hard to understand. Let's turn them into graphs to make them easier to understand. So let me introduce you to some of them and see if you can find use for them. This is one of my favorites. It's called the cause and effect diagram, the fishbone diagram, or in reference to Mr. Deming's contemporary in Japan, Mr. Ishikawa, also called the Ishikawa diagram. So you can call it cause and effect, Ishikawa, or fishbone. What it is, it's a way of brainstorming. You've got a defect, a quality issue happening. Very rarely is it a single cause, and you can use a diagram like this to figure out, well, what are the potential causes, plural, of this major defect? And you can list them like this. And there could just be 1, 2, 3, or in this case, there could be 8. Excuse me. So that's what it is. It's just a wonderful brainstorming. So, a major defect, let's just think of a humorous one. Staff don't turn up for work on time on Monday mornings. That's the problem we're having. Potential reason is tired after a weekend, or don't like their job, or stuck in traffic, or weather, or I don't know, many other reasons, but you can come up with all the reasons. And then the other thing that I like to add to this is called the 5 whys analysis. Why? Now, I actually, at the time of recording this, I have a 3-year-old son, and he's right in the middle of this phase at the moment. So just the other day we were driving around and he wanted to know what that road sign was. And I said, that's a sign that says how fast we're supposed to drive. And he said, well, why does it tell you how fast you have to drive? And I said, we want to stay to the speed limit so we stay safe. He goes, why do you want to stay safe? And I said, well, we don't want anything to happen to you or the car or anybody else. He goes, why don't you want anything to happen? He actually said, why don't want anything to happen to the car? Like, well, that wasn't actually my top priority. It was more about you. But yeah, he did this quite a bit. So keep that in mind. So here you might want to get to the root cause. So that's what you're really trying to do with this analysis, is get to the root cause. Because if you can keep asking, so if this was staff not turning up for work on Monday morning and you decided that it was traffic. Why was traffic a problem? Because the staff will drive their own cars. Why do they drive their own cars? They drive their own cars because there's no good public transport. Why is there no good public transport? And you can get to the root cause. And what you want to do is solve the root cause to deal with the issue. Because solving any higher level cause is not actually dealing with the issue. You're just merely putting a band-aid on it. So I like to combine cause and effect, Ishikawa and fishbone, with 5 whys analysis as well. There's software that'll do all this for you too, by the way. You can, there's plenty of bits of software that will help you do this sort of analysis of all your potential causes and then figure out the ones. The control chart's a really interesting one. Here, this is you're making something for a client. The easiest way to demonstrate this is just to say that. You're making something for a client. Now, they've set the specification limits here, the lower and upper specification limits. If you make anything within these specification limits, they will take it from you. Okay, so it could be some sort of tolerance level or something like that. But the specification limits have been set. Anything outside the specification limits, no, the client's not paying for, nor is it any use to them. Okay, so within the specification limits, you set your expected mean, what you expect in terms of what you're measuring. 3 standard deviations either side of that mean, you will set your upper and lower control limits. So theoretically, 99% of everything you produce should be within these in the upper and lower control limit. That's where they should be. So this tells you, first up, if you produce something and it measures out here outside the specification limit, the client's not going to pay for it. If you produce something and it's outside the control limits but within the specification limits, that tells you this shouldn't really have happened, low probability, go and investigate why. But there's another reason you should go and investigate why as well, and it's called the rule of 7. What it is, if you get 7 consecutive points on one side of the mean, so here we're getting some on that side, some on this side, that side, like this. It's all over the place. But here, 1, 2, 3, 4, 5, 6, 7 all appeared below the mean. Now, a simple way to give you an example of this, if I gave you a dice, a 6-sided dice. Do I say dice or die? I think you're supposed to say die for singular, aren't you? If I gave you a 6-sided die to roll, and you started rolling it, and you got a 3 and a 2 and a 5 and a 3 and a 6 and a 1 and a 4 and a 2 and a 3 and a 6, and then all of a sudden if you rolled 7 6s in a row, you might start to go, although that's possible, it's improbable. Therefore, maybe the dice is loaded. Or again, if I gave you a coin to flip, heads and tails, and you're going heads, heads, tails, heads, tails, tails, heads, 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 tails, tails, and you tossed 7 tails in a row, at that point, that's a statistical anomaly, and you may want to go and investigate it. So that's what the rule of 7 is. It's just a way, it doesn't tell you anything is definitely wrong. Like being outside the control limits but in the specification limit, it's just saying, hey, this is improbable, maybe you should go check that this isn't indicating that something that you're producing is about to go out of control. The other one is Pareto's law. Pareto, I want to say Nikolai Pareto. Again, I'll use my phone, it's right next to me. I want to make sure I give you the right information. You might be at a dinner party and the conversation's drying up and you might want to impress people. Vilfredo, sorry, I got it wrong. It's not Nikolai, it's Vilfredo Pareto from 1848 to 1923. He put out a book that was talking about the income distribution in society, Italian society at the time. And he pointed out that at that point in time, 20% of the population in Italy owned 80% of the land. And that became known as the 80-20 rule. And by the way, if you're ever at a dinner party and the conversation's dried up so much that you think you need to bring up Pareto's law, you need to get better friends. Anyway, moving right along. And that became the 80-20 rule. So what it says is if you track all of your quality issues, you probably won't find that they're equally distributed, that there will be a certain percentage of your quality issues that are causing the most problems. And you should focus on those. And if you focus on those, you'll get most bang for your quality buck. So in this case, these are some noises that you hear coming out of a car. We've tracked them as a percentage, the number of defective cases, and that's the percentage there. So here it's about, 30, we'll call that, so about 37%, 25%, and here looks like about 20%. So you just add all these up until you get to 80%. So you draw a line here, I guess that's about 80 there. You draw it across, is 80%, draw it down. And what you've just discovered is that these 3 causes contribute 80% of your problems. So why not focus on these? If you can deal with these 3 issues, you would have dealt with 80% of your problems. So the Pareto chart is just a great way of tracking issues with quality so you can actually focus your attention. Again, software does all that for you and should be in your reporting. The run chart, the next couple of diagrams you know already, you've seen them in Microsoft Excel. The run chart is just plotting variables generally over time, just showing you. So you can do trend analysis. If you want to do trend analysis in Microsoft Excel and you've got a line like this and you're going, what is it actually doing? You can right click on that line and go insert trend line, and Microsoft Excel will tell you which way it's heading and things like that. So what you're looking for here is trends or variances, and you can spot, in this case, if I would expect Microsoft Excel to draw a line that probably looked a little bit like, probably more like that, I would take a guess, which clearly shows it's going down. That may be a good or bad thing. So simple run chart. Then the other one that you already know is another one, 2 variables to each other. So one of them isn't time, and you're looking to see if there's a relationship between them. So in this case, if that was your output between solution viscosity and agitator speed, you would say there is a high degree of interrelationship between those 2 variables. If there wasn't, they would be scattered all over the place. So obviously that's what that indicates. So scatter diagram there. And then the last technique that I'll introduce you to, because there are quite a few others, but you only need a high-level introduction to quality management at this point. And the particular tools and techniques that you use will already be defined by your organization. And does this apply to coding, by the way? Well, this one does, and so do some of the other too. So it's not just about real like construction techniques. This applies to agile and iterative projects too. The last one is statistical sampling. This is testing a small sample of a product and then extrapolating from that the results refer to the whole population. And you choose to do this because it's too costly to test everyone, or too dangerous, or your testing method is destructive. So for example, the example I always give, the bicycle helmet that I wear says it complies with the local standard. Well, I know that bicycle helmet's never been tested, because the testing for bicycle helmets is destructive. They take a large metal pole with a point on the end of it, they lift it up to predetermined height, and they let it swing down and hit a bicycle helmet, and it's only allowed to penetrate it so far. So that's destructive testing. So you can't test every helmet. You may use statistical sampling for code. So maybe you're doing software code, and maybe there's a lot of code, thousands of lines. Now, you might be using pair programming. That's absolutely fine. That'll pick up a lot of these issues. But maybe you've got 1,000 lines of code, and maybe instead of reading every line of code and testing it, you actually just choose bunches of 100 lines or something like that and test that, and sort of go, well, we do write code pretty well, and therefore we're not expecting any bugs. So statistical sampling is a great way to do it. So look, that's my introduction, high-level introduction to quality management. Again, it's just about reinforcing a few points about that you should have a quality management plan. You should be thinking about quality on your project, what it means to you, what the cost of quality, the cost of poor quality is. So have you been paying attention? Here we are. This is the words and the definitions. So we got the words on the left-hand side and the definitions on the right-hand side. The words are quality, 80-20 rule, total quality management, grade, and control chart. So give you a second there. What is the best definition of quality? Is it A, B, C, D, or E? Actually, one of the things I realize is instead of me leaving a pause here, I could just be telling you just press pause on the play button, rather than me having to wait for you to read all of those. So maybe that's what I'll do. But I've done most of the modules. This is one of the last modules I'm recording, by the way. So I should have thought of it at the beginning. It's a quality process for future ones. Anyway, hopefully you said that quality is C, the management of the degree to which a set of inherent characteristics fulfills requirements. What is the 80-20 rule? Is it A, B, D, or E? Hopefully you chose a way of explaining that the majority of quality issues come from a small amount of causes. What about total quality management? What's total quality management? Is it B, D, or E? Well, hopefully you chose B, a business management and quality strategy aimed at embedding awareness of quality in all organizational processes. The final two, grade and control chart, you've got a choice between D and E. Nice and simple. Grade is in fact D, a description of the features or function that a product is supposed to have, and it differs from quality. And finally, a control chart, just that wonderful chart with the specification limits, control limits. It's a way of measuring expected means and tolerances of a product being produced to ensure the process stays in control. So there we are. There's your quick high-level introduction to project quality management. So please, it is better to build quality in rather than try and fix things afterwards. Poor quality affects the entire product life cycle. So emphasizing that decisions you make to save money on the project could mean that the product owner or asset owner has a lot of costs for them. Always start with a quality management plan as part of your project management plan. Do quality assurance, so do your checks, have a checklist of when they'll be done. Will they be done on a regular basis? Will they be done on random checks? Will they be done under predefined conditions? And allocate time and resources in your project scope statement to quality work, so you know that it's part of your expected project deliverable. And that, remember, is different from the product deliverable. And then carry out all of your quality control to check that whatever you're producing is of the desired and defined quality. So there we are. Once again, we've come to the end of another module. I'm assuming this isn't the first one you've watched. It'd be strange if the first one you went into was quality management. So look, thank you so much for your attention. I'm grateful for it. And as with all the other modules, if you do have any questions at all, email me and I will do my best to get back to you as fast as I can with an answer to your question. But in the meantime, thank you very much, and yeah, have a great day.